Welcome to another Grandmaster video. Today I'm going to teach you about refraction of waves. In order to understand this concept better, I will use PHET simulations, which were created by University of Colorado. In order to get to their website, we will type PHET or PHET on Google search, and then we have to go to phet.colorado.edu website, which is usually the first search result we can observe in the Google. This is a very interesting website. It contains many simulations on physics, chemistry, biology, and mathematics, which is mostly suitable for A-level and O-level or IGCSE students. Not even O-level, like even for grade 6, 7, 8 students, this is very suitable. So you can understand most of the scientific concepts easily using these simulations rather than just reading a text. By looking at these simulations, we can grasp the concepts better. So there are many simulations. Already they say that they have delivered 806 million simulations, and all these simulations are free. Therefore, don't hesitate to make a donation to these guys. It's really helpful what they are doing. They help us to understand the scientific concepts. So if you are capable, make sure to make a donation. Now we'll move on to simulations page. So we have several simulations are categorized under several subjects: physics, chemistry, mathematics, earth sciences, and biology. Since I'm going to explain you about refraction of waves, we have to select physics. In physics simulation page, you can also find many other simulations which are really interesting. Simulations on different topics in physics, in electricity, Newton laws, energy, Faraday laws, motion, forces, gases. So you should be able to understand most of the concepts by studying or by playing with these simulations. I will select bending light for this today's lesson, which is refraction of waves. Now you don't have to download most of these simulations. Some of them you will have to download, but most of them you don't have to download because they support HTML5. So you should be able to run them on your browser itself. So I will select bending light simulation, and then we have to click the play button, which will take us to the simulation page. So in the simulation page, we get three options: introduction, and then prisms, and more tools. In order to explain the refraction, first I will move on to more tools page. Here you can see that there are two media. The top medium is air. The bottom medium is glass. And we have a laser generator. By pressing this red button, we can switch on the laser beam. If you want, you can also change the ray form into waveform using this option button. And then you can observe the waves in the waveform with wave fronts. These red lines represent wave fronts of a wave. If you want, you can also change the wavelength of the wave by sliding this slider. I prefer the ray model, ray form, In order to describe these concepts, it's much easier, but in some situations I will use waveform, but for now I'm going to use ray model, ray mode. First of all, we'll try to understand what is refraction of waves. We know that wave is a method of transferring energy. So when a wave travels through certain medium, it has a speed. But waves have different speeds when they are traveling in different media. I will show you this with this speedometer. We have a speedometer to measure the speed. Now, this light ray or the beam is in air. So if I measure the speed of this light, it shows us as 1.00 c. Here the symbol c denotes the speed of light, which is 3 times 10 to the power 8 meters per second. So this is the speed of light in air or in a vacuum. And if you try to measure the speed of light in glass, you should see that's around 0.67 c, which is 3 times 10 to the power 8 multiplied with 0.67. That gives us around 2 times 10 to the power 8 meters per second. So this shows us that speed of light changes when it travels from one medium to another medium. This is valid not only for light rays, this is also valid for all the types of waves. When they travel in different media, they travel with different speeds. So when a wave travels from one medium to another medium, due to this change in speed of the wave, the original path of the wave is deviated, or the direction that the wave was traveling will be changed. This phenomenon is known as refraction of waves. Now, in order to explain about this refraction of waves, we will first identify few features which we can observe in a refraction of waves. In order to do that, I will shift back to the introduction page. It's much convenient. So we have in light ray, and on the top we have air, at the bottom we have water. So the light ray, which you can observe above this middle line, which we call this as the interface. This line is called the interface. That is the interface between the two media. So the line or the ray above this interface, which is coming from the laser generator, is known as incident ray or incident wave. And the light ray, which is traveling in the second medium or water, is called refracted ray or refracted wave. If it is a different wave, you can see it as a refracted wave. And also you can observe that there is a dotted line between the two media. This dotted line actually is perpendicular to the interface, and this dotted line is known as the normal. Remember, this dotted line is an imaginary line. It does not exist. It's an imaginary line. Now, we can identify several angles in this. Angle between the normal line and the incident ray is called the angle of incidence, and it is denoted with I. And the angle between refracted ray and the normal line is called angle of refraction, and it is denoted with simple R. You can also observe that there is another light ray, which is a reflected ray from the interface. I will explain about this ray later in detail, but this is a reflection. We actually call it as a partial reflection. Now, if you remember the reflection of waves or reflection of rays, we have two rules to describe about, two laws to describe about reflection of waves. The first law is angle of angle of incidence is equal to angle of reflection. Don't get confused. I'm explaining about reflection of waves. If you are not familiar with the concepts of reflection of waves, please search on my channel the video that I have explained about the reflection of waves. So in reflections of waves, angle of incidence is equal to angle of reflection. So we want to obtain a similar relationship between angle of incidence and angle of refraction in a refraction of a wave. But it won't be very simple as in reflection of waves. We get a slightly different relationship. Before I come to discuss about this relationship, we will learn about two types of two methods that a wave can get refract. Stay tuned to our channel. With this next video, I will explain you the two methods of refraction.